Hello everyone, my name is Ashley Goodnight and this is my Reading Week 4 video. The main concept of this week was projectile motion. Given information like the initial position and velocity vectors, we can answer questions such as, when does the ball reach its maximum height? What is the maximum height? And how far has the ball traveled when it is at its max height? To solve these projectile motion questions, we can plug in information provided into our code for a falling object, or we can also solve the problem analytically, that is, with pen and paper. To solve projectile motion problems analytically requires a bit of basic calculus. From Newton's second law, we can derive the position and velocity equations for the x direction, shown on the left, and the y direction, shown on the right. The main advantage to using the computer model to solve projectile motion is the ease of incorporating drag force. To account for drag force, you just need to add the appropriate value to the coefficient b. However, to solve for drag analytically, you must solve a series of differential equations, shown on the right, which is doable, but time-consuming, and takes away from understanding the physics. Still, in this fourth week, I find myself re-watching the video lectures for a better understanding using Tracker and GlowScript. Fortunately, I find myself improving in some areas I found difficult and confusing. I am now able to trim parts out of the video, adjust the coordinate scale, plot the approximate centers of mass for each time frame, and this week I learned GlowScript's Control F. In order to change sections of code quickly, simply go under Edit, Replace, and Find before inputting what word or phrase you want to replace and the words or phrases you want to replace them with. In the video example, the narrator replaced the word ball with earth to better fit the problem. In order to keep up with the great improvement, I used this website called Trinket, which gave actual coding practice applying Python to physics problems. The link is in the bottom corner of the screen, but it's easier to just Google Trinket Physics through Python. Having taken physics before, I had the basic understanding of Newton's third law that states, for every action, there is an equal and opposite reaction. This phrase succinctly covers the concept of reciprocity. However, what I was not aware of was that the electric force, or more properly the electrostatic force, which is described by Coulomb's law, also exhibits reciprocity. As I have mentioned in previous weeks, I am majoring in electrical engineering. At Georgia Tech, EE majors are able to select threads, or areas in electrical engineering we can delve deeper into studying. One of the threads Tech offers is called Signal and Information Processing, which uses computers or digital hardware to extract information or to transform the signals in useful ways. We are doing this in physics by using computer modeling software, like Tracker, to extract position and time values, and transform the signals with GlowScript and predict future movement and test fundamental principles of physics, like Newton's second law. With that, I am concluding my presentation. Thank you everyone for listening. See you all next week.